As we continue our discussions of experiments and surveys and observational studies, we've talked about how we are oftentimes going to use just a sample of a population, and of course we need to know how confident we are in the results we're getting. And so there we have a measurement called the confidence interval, and it is the estimated range within which a number will fall with a stated degree of certainty. So we're going to try and be 95% certain that these numbers or these results fall within a certain range. And it's calculated by, its confidence interval is the X bar, and of course that's the mean for a sample, plus or minus 2 times S, and S is the standard deviation of a sample, divided by the square root of N, and N is the number of people that we surveyed. So here's an example. We surveyed 100 random people, and we asked them how much they exercise each day. The mean of their answers was 25.3, and the standard deviation was 9.4 minutes. And we want to determine with a 95% confidence interval where these numbers will lie. And we're going to round our confidence interval to the nearest tenth. We want to round our this number, and we'll talk about it when we get there, is to the hundredth, and then we'll round our confidence interval to the tenth. Well, if the X bar plus or minus 2 times S over the square root of N is our formula, 25.3 is our mean, that's our X bar, the mean of the sample, plus or minus 2 times 9.4 was our standard deviation for the sample, S, and we're going to divide that by the square root of 100, and 100 was the number of people that we tested. Well, 2 times 9.4 divided by the square root of 100 is 1.88. So we take that 1.88 and we subtract it from 25.3 to get 23.4. We take 1.88 and we add it to 25.3 to get 27.2. So the mu is the mean of the population. So with 95% confidence, we know that the mean for the population lies somewhere between 23.4 hours and 27.2 hours. Usually, before we ever start testing or creating an experiment or doing observational studies or taking a survey, we think something might be true. And we want to test it out. We want to find out if it's true or not. And so we have come up with already probably some sort of hypothesis. And we want to see whether that hypothesis is true or not. And what we do is we make a null hypothesis. And a null hypothesis is a statistical hypothesis that is tested for possible rejection under the assumption that it's true. In other words, we want to test to see if it's not true. And the contrary to that, the contrary to the null hypothesis, is the alternative hypothesis. And so to test that hypothesis, we'll design an experiment. We'll conduct the experiment and collect the data. We'll find the confidence interval and then make a correct statistical inference. We'll accept the null hypothesis if the population parameter falls within the confidence interval, and we will reject the null hypothesis if the population parameter falls outside of the confidence interval. So we have a team of students that comes to us and they claim that the average student studies 27.5 hours per week. And we go, nah, prove it. So they design an experiment and they test that null hypothesis. The null hypothesis is, no, there's less than that. All right, we think it's probably less than that. So we test to see if it's greater than 27.5 hours per week. And they decide to test write a questionnaire, a survey that they give out to the students. And they tested 10 students. And they found, X bar, the sample, had a mean of 29.2 and a standard deviation of 5.3. And so they calculated their confidence interval. They plugged in the 29.2 for the mean of the sample, plus or minus 2 times the standard deviation, which is 5.3, divided by the square root of the number of people that were tested. I'm not sure why they have 100 out here. It's definitely 10 students they're testing. And so 29.2 plus or minus 3.35. And again, once we add and subtract it to that number, we'll get a confidence interval of 95% between 25.85 and 32.55. So the null hypothesis, HO, overlaps the confidence interval. So the students should accept the null hypothesis. They have not proven that the average student at their school studies at least 27.5 hours. Some of them study much less than that.